Good afternoon. I'm Timothy Precella. Today we're going to look at solving inequalities using cut points with our Math 13-14 class. And first thing I want to do, I've given you all this handout. So as you come in, pick up a copy of the handout that I'm going to put right up here in front of the classroom. And right here. Okay. The cut point method is really an amazing method for solving inequalities. Remember, I mentioned the last time that an inequality is anything that has an inequality symbol, a less than, a greater than, a less than or equal to, or a greater than or equal to. This is a very logical method for solving inequalities. The first thing we do is we ask ourselves, when is the inequality equal? When will the left side equal the right side? And the numbers we get here are called solution cut points. Then we ask ourselves, well, when is the expression not even a number? Maybe it's undefined sometime. We already know when something's undefined. We've seen undefined expressions. They occur when the denominator is equal to 0. Something like a number over 0. That's what you're looking for here. These names are called these numbers that you find are called denominator cut points, and you always label denominator cut points with an open circle. You never want a denominator of 0. Then you'll draw a number line and label those cut points. You'll test the intervals that are created. Something can't change from less than 5 to greater than 5. I'm just using the word 5 as an example. You can't have something change from less than 5 to greater than 5. Think about a number line. What happens right between less than 5 and greater than 5? It equals 5. The other time when something can change from less than 5 to greater than 5 is if the expression isn't even a number. That's that part number 2. So we have this number line with a series of intervals. We go through choosing a number, testing the inequality. If the inequality is true, we'll shade the interval. If the inequality is false, we're going to cross out the interval. And finally, this is what we reviewed at the end of class last time. You're going to wind up with a number line with a series of shaded intervals. You have to express the shaded interval using interval notation. Remember, I said you use those square brackets for closed circles. Use parentheses for open circles. You also use parentheses for infinities or negative infinities. The only time you'll use a square bracket in interval notation is if you have a closed circle on the number line. I like to do a problem that illustrates all 5 steps. So that's how I like to start off. So we're not going to start at number 1 in this assignment. We're going to start at number 5. And let's see. Number 5. And there. We want to solve the inequality. 4x divided by x plus 2 is less than or equal to 5. Let me write this down first. Okay. And let me switch. We're going to follow this little recipe, this cut point recipe, to solve the inequality. The first thing you do, you ask yourself, when is the left side equal to the right side? Replace the inequality with an equal to and solve for x. We know how to do that. We know how to solve an equation of this form. So this is step number 1. Since this is the first example that we're doing of using cut points, I'm going to number the steps. First thing you ask yourself, 4x divided by x plus 2, when does it equal 5? I think I'm going to think of that 5 as a 5 over 1. Now, why am I doing that? When now I have a fraction equals a fraction, how can I solve a fraction equals a fraction? We say cross multiply, that's what I want to do here, okay? I'm going to cross multiply there and there. 4x times 1 is just 4x. 5 times x plus 2, we're going to have to distribute the 5. What's that going to give us when we distribute the 5 over the x plus 2? 5x plus 10, I agree. Now we're trying to solve for x. I think the easiest thing to do is to maybe subtract that 4x from both sides, but then what are we going to have to do to this 10? Move it over to the left by subtracting it. So, Tony, you can go on. We're taking care of this all on our own. I got the wall open. I got it. Oh, watch me not be recording. Yeah, I am. So 4x minus x, that disappears. We move the 10 over. So we have a negative 10 is equal to, what have we got here? X. And notice the little recipe. The numbers we get here are called solution cut points. I'm going to be abbreviating them SCP for solution cut point. This is my solution cut point. It's going to have to be labeled on the number line. When you're labeling numbers on the cut points on the number line, they'll either be open circles or closed circles. To determine whether it's an open or closed circle, you have to decide, does negative 10 make this into a true statement? If you plugged in negative 10, you'd get 5 is less than or equal to 5. Would that be a true statement? 5 is less than or equal to 5. Write out 5 less than or equal to 5, just on the scratch. 5 less than or equal to 5. Plugging in negative 10 would make this thing equal 5. Is that a true statement? Yes, because of the equality. Suppose there hadn't been equality. Would 5 less than 5 be a true statement? No. So notice we're specifically telling you how to decide whether to label with open or closed circles. If the problem contains a less than or equal to or greater than or equal to, you label your solution cut point with a closed circle. If it's just a less than or a greater than, you'll use an open circle. So for the solution cut point, this thing here, there's equality. We're going to have to label it using a closed circle. The first thing we do, we ask ourselves, when does the left side equal the right side? When is the inequality equal to? The second step, step number 2, it's a short one, so I can do it right here. You ask yourself, when is the expression undefined? We've dealt with undefined fractions. A fraction is undefined when the denominator is 0. So look at what the second step says. Set any denominators not equal to 0 and solve for x. The numbers you get here are called denominator cut points. There's only one denominator, that x plus 2. You don't want that to be 0, so x cannot equal negative 2. These numbers are called denominator cut points. And notice how I say to label it. Always label denominator cut points with an open circle. These negative 2 would give you negative 8 over 0. That is not a number. You can't have a denominator of 0, so it doesn't matter what the inequality is. On the second step, the denominator cut point must be labeled with an open circle. So we found our cut points. We have 2 cut points. We have a solution cut point of -10. We have a denominator cut point of -2. Third step, draw a number line and label the cut points. So here's step number 3. I'm going to draw a number line. And label the cut points. Now they have to remember this is a number line. The smaller number has to go to the left. So which one's smaller, -10 or -2? -10 is smaller, and then -2. -10 we said label with a closed circle. -2 we label with an open circle. Now we have to figure out which intervals are going to be shaded. So look at step number 4. Select a number in each interval and substitute it into the original inequality. If the inequality is true, you're going to have to shade the interval containing the test value. If the inequality is false, cross the interval out. There are 3 distinct intervals here. So I'm going to test 3 intervals. This is step number 4. We're going to see a way to avoid having to test every one of these intervals. But for the first example, I'm going to test all 3 intervals. I need a number to the left of -10. I could use -50 million, but use something that's easy to plug in. What do you think we could use over here to the left of -10 that would be easy to plug in? -11? Okay, we'll test -11. Between -10 and -2. Could negative what? -4. -4. You could use -3. If you want to use an integer, you could use -3, -4, -5, up to -9. We'll test -4 then. And then to the right of -2, I'm going to test 0. If an interval contains 0, I always think 0 is the easiest number to plug in, as long as it's not a cut point. If 0 is a cut point, you can't test it. But to the left of -2, we're going to test 0. Might want to open up that calculator in a moment. Tony? Okay, plugging in a -11. You're testing the original inequality. 4 times -11 is -44 divided by -11 plus 2 is -9. Is that less than 5? Negative divided by negative is positive. So what is that? That would be 4 and, let's see, 8/9. Would that be 4 and 8/9 if you wrote it as a mixed number? Maybe y'all like it better if we wrote it as a decimal. What's -44 divided by -9?
4.8888.
So basically a 4.9 is less than 5. True or false? True. It's true. If the inequality is true, shade the interval containing the test value. It's true, so we shade. Now we're going to plug in -4.
Can I interrupt for just a moment? At this point, if y'all knew what I meant by the word alternate means, if this first one is true and it's alternating, what would you guess the next interval is? False. And the following interval? True. Most of the times it'll alternate. We'll show you how I can look at it and tell, yeah, it's going to alternate after we've done this. Okay? But if you ever find yourself getting true, true, or false, false, more than likely you're messing up. There's about an 85% chance. What would you think?
That they're messing up, yes. Okay, -4. Plug negative 4 into the original inequality. 4 times negative 4 is negative 16 all over. Negative 4 plus 2. Negative 4 plus 2 is negative 2. Is that less than 5? Negative 16 divided by negative 2 is 8 is less than 5. True or false? False. Cross it out.
Now I notice you're just saying less than because you know it's not equal.
I know it's not equal to. The only time it would be equal to 5 is at that solution cut point. Finally, testing 0. 4 times 0 is 0 divided by 0 plus 2 is 2. 0 divided by 2 is, don't say undefined, 0. Is 0 less than 5? Yes, so we shade.
Now it's like what we were doing on Monday. You have the number line with the cut points labeled.
We've gone through the first 4 steps. We found our solution cut point. There it is, step 1. We found our denominator cut point, step 2. Step number 3, we drew the number line. We did the testing in step 4. So now we're ready for step 5. That's what we were doing at the end of class the last time. This thing doesn't stop. It keeps going to the left. So what do I use to represent that idea that the number line just keeps going to the left? A negative infinity and over on the right. So I'll get us started. Remember I said you always use parentheses for infinities or negative infinity. So you have a parenthesis, negative infinity, comma. Oh, and for these interval notation, you must go left to right. You can't put negative 10 first. It has to go left to right. The right-hand endpoint is a negative 10. Since it's shaded circles or closed circles, use square brackets. And then you use a union symbol that you'll have in the toolbar. So the numbers that are less than negative 10, including negative 10, will make this into a true statement. Or these numbers over here. Pretend I'm about to type this thing. What would I write first, parentheses or bracket? Be careful.
She said I heard parentheses.
Oh, did he say parentheses or bracket? Oh, I thought I heard bracket.
Okay.
Bracket, okay.
I always hear the right answer.
Parentheses, negative 2, comma, infinity, and what always goes after an infinity? Here's the stuff you're going to have to type in.
Let me see if I've been logged out.
Before, okay. Go ahead.
I want to type it in before we get logged out. Parentheses.
Notice there's no negative infinity on the toolbar. There's only an infinity. How do you get a negative infinity? You type the negative from the keyboard, and then you click the infinity. You laugh, but I'll get emails about that. I'll get emails. There's no negative infinity symbol.
The square bracket is just from the keyboard.
The square brackets, they're just from the keyboard also. I would not use these parentheses here because that's an ordered pair. Okay, so for the parentheses and brackets, type them from your keyboard.
You might be sitting there thinking, oh my gosh, this cut point method is so hard. And I always tell students the same thing about this cut point method. First time I was solving these in college, our teacher had a method called think about it.
Just think about it.
We just sort of wrote the problem down and thought about it until we came up with this answer. I assure you, thinking about it. The first time I finally saw these steps, I felt like an idiot because we had back then paper books. The paper book had the steps. I mean, why didn't I look through the book and, oh, okay, I'll follow these steps. rather than doing what the teacher said. Think about it.
So you're telling them not to do what the teacher says.
Yeah, well, you're right. I am.
Okay.
It's coming out like that. That's not what I meant.
Okay. I like to start off with the problem that illustrates all 5 steps. We didn't skip any of these steps. Do you agree? Now we're going to go back to, let's just do number 1.
Wait, can I tell them when it's going to factor and when it's going to alternate?
I'm going to do it in this next one.
Oh,
I think it's better because we're going to have to factor in the next one.
But we did it on this one.
You'll notice we didn't.
Did we have to do any factoring on this problem 5?
No, there were
It's
no
gonna
x squares. It's going to alternate.
So
okay?
how does that make it easier for you? You don't have to plug in all of these numbers. Choose the number you think is easiest to plug in. I still think 0 is the easier one to plug in. And once you know that one's true, then what do you know about the others?
You have to assume the one beside it is false. You don't have to assume. You could choose a number and test. But I'm telling you, if it's all linear factors, there were no x squares here, you wind up, and you know that's true, the one beside it's false, the one beside that is true, and so on.
I used
look
to
at number
tell
1.
students test every interval because that's what the book says. But once I started saying, hey, it usually alternates, then students started making fewer mistakes. Okay?
It's true. The more intervals you check, the greater likelihood that you're going to make a mistake. Okay?
Which is a
So if you
terrible
can
thing.
just check one interval and be confident that's right, then you know the one beside it will alternate, that it's going to start that alternating pattern.
Mm-hmm.
Now let's go to number 1.
I think I better turn to another sheet of paper.
I don't think I need to. I think I'll be okay right here. What do y'all think? I better turn to another sheet of paper. You're right. This is number 1. Number 1, not number 14. This is number 1. Let me write down the problem. X squared minus 14x plus 40 is greater than 0. I assume that things went okay. I hope the Vice President didn't have to chew you out or anything.
No, but everything went great.
I'd already told him it was just a committee meeting, so no.
But I would have.
Use this cut point method as assignments aren't when we think, oh, the assignment isn't long enough, this is one of our favorite things. Okay, there's only 13 problems in the assignment, stick on 2 cut point problems just so you don't forget them. Okay, but this is not going away. It's going to be appearing every few assignments. At the end of the assignment there'll be some inequality that you can solve, that you'll need to solve using cut points. Now I want to know, look at this problem here. This is number 1. I didn't want to start with this because one of these 5 steps we're just going to skip. Which of these 5 steps are we going to skip? Number 2. In order to have denominator cut points in the problem, the inequality must have denominators. Do you see any denominators there? So if your inequality doesn't have fractions, you're just going to wind up skipping over step number 2. But let's get going. Number 1, replace the inequality with an equal to and solve for x. So first thing we'll do, I'll number the steps again. And this is a simple trinomial. I'll write my 2 sets of parentheses. I see something that I like here.
How did you know you needed to factor that, Tim, in case someone's wondering it? Because of the x squared?
Yes, that's right. And so x squared would be, and this factoring step is important. When you have a quadratic expression, this factoring step is important. X squared, and I'll tell you why in a moment. X squared would be x times x. What do we know about the signs? Second sign's a plus, so you have 2 of the first sign. And now for 40. 1 times 40, 2 times 20. No, 3 doesn't go evenly. 4 times, here they are. I'll write them out. 1 times 40, 2 times 20, 4 times 10, 5 times 8, 6, 7, we're back to 8. There it is. This is a simple trinomial. It's simple to choose the pair you want. Which one will we use? I couldn't hear you. 4 and 10 or 10 and 4, depending on how you want to, whichever one you want to write first. And if you track the outer and the inner, negative 10x minus 4x, does that give us negative 14x? Yes. So you set each factor equal to 0. You set x minus 4 equal to 0 to give you a solution cut point of x equals 4. You set x minus 10 equal to 0 to give you a solution cut point of 10. These are my solution cut points. How am I going to label them? Solution cut points make the left side equal the right side. Is it okay for the left side to equal the right side here? I couldn't hear you. No, because there's no little horizontal bar. Remember, I said we spell it out here on this recipe. If the problem contains just a less than or a greater than, no equal to, you're going to use open circles.
Years ago, a student told me that he had a good way of remembering which of these, this, and his method was, look at the symbol, what uses more ink? A closed circle or an open? Well, a closed circle uses more ink to draw. Which symbol uses more ink? The stuff with the equal sign uses more ink. And I thought that was such a good little way he had of remembering that, and I mention it every semester. Did y'all follow what the rule was? It's not my rule. It's just whichever one uses the most ink. A closed circle uses more ink than an open circle.
But keep in mind that only applies to solution cut points. If we had denominator cut points, it doesn't matter. Denominator cut points, you never want a denominator of 0, so you always label denominator cut points with open circles. Second step, y'all have already said, set any denominators not equal to 0 and solve for x. There are no fractions in the original problem. So I'm going to write this out. I wouldn't expect you to do that, but this is my logic. I'm going to skip because there are no fractions. There are no denominators to ever equal 0. Third step, we draw a number line. Let's see, which one are we going to write first? Remember, it has to go small to big. This one here. The first cut point. 4. And then, and notice, and we said they'd be open. Notice, when I choose my test value, I don't label that test value on the number line. Look back at the previous problem. Your answer, that's the wrong word. The answer that you get, the interval notation, all it can have are infinities or negative infinities and cut points themselves. Negative 10 was a cut point, negative 2 was a cut point. The number that we tested, negative 11. Was negative 11 written down here in your answer? What about 0? We tested a 0. Was 0 written down here? I guess you can say, well, yeah, there, it's part of the 10. No. What about negative 4? The test values themselves do not appear within the interval notation. If I had labeled a little tick mark and put a 0 here, you'd be surprised how many people decide to use that 0 in their final answer, and it's not used. So, let's come back. Here we are. Look at the factoring stage. did we get repeated factors? Did we get the same thing inside both sets of parentheses? Say no. We got an x minus 4 and an x minus 10. They're two distinct factors. I'm 100% confident then that this thing's going to alternate. It's either going to be true, true, or false, true, false. When you have repeated factors, that's where the problems start. That's where you could wind up. If that had been x minus 4 and x minus 4, we could have written it as an x minus 4 squared. If you have repeated factors, no matter what you plug in there, you're not going to get a negative result, because whether it's positive or negative, when you square it, it stays positive. It's those repeated factors that cause a problem. When I went through and I factored this and saw that there were two different distinct factors there, I knew it's going to alternate. We're not going to have a true, false situation. At the end of class, if we have time, I'll make up one where it's a true, false, or a false, true, something like that. But no repeated factors, so I'm confident this is going to alternate. I'm only going to test one interval. What's the easiest number to plug in? 0. Which interval contains 0? Interval 1, 2, or 3? 1. Okay, so we're going to test 0. 0 is to the left of 4, so I'm going to test 0. I guess so.
Zero, sometimes students have trouble figuring out where is 0 on a number line. 0 will always be between a negative and a positive. Right? It can't be between two positive numbers. 0 can't be between two negative numbers.
Plugging in 0, we get 0 squared is 0, minus 14 times 0 is 0, plus 40 is greater than 0. We plugged in 0. Did we get a true statement or a false statement? True, that says 40 is greater than 0. So we shade. That's a true statement. If the inequality is true, shade the interval. Suppose we tested 5. What do we expect to have happen? Between 4 and 10, suppose we tested 5 or 8. Do we expect it to be true or false? False, so we'll cross it out. Suppose we tested 11 or 100 to the right. True or false? We expect it to be true. So, fifth and final step. Hey, am I going to have any rectangular brackets in my interval notation? Will I have any rectangular brackets? Rectangular brackets occur where? At closed circles? Do I have any closed circles in here? No. So all my symbols of grouping will be parentheses. Left parenthesis, call it out as if you were typing it in. Left parenthesis. Negative infinity. Before you put the 4, you have to type a comma, and then the 4. What goes after the 4? Okay. And then that union symbol from the toolbar. All the numbers to the right of 10. I heard a bracket. Is that a bracket? Parentheses, open circles. You only use a bracket for closed circles. Use parentheses for open circles. Use parentheses for infinities or negative infinities. So parentheses, 10, comma, close parentheses. Left parenthesis, negative infinity, comma, 4, right parenthesis, union, and it's the U, not the intersection symbol, okay?
There's no time they should use this
There's
symbol
no
this
time
semester.
that you should be using that upside down U this semester.
No, this is one of the times when I can use this.
Oh, I think that's a
I
bad
don't really
habit,
like
but
it, but 10, because I got to then click here, and what do I put?
infinity.
There. So these things alternate. Why don't we write it right here? If you don't have to factor, they
If they're-
alternate.
If there's, I'll say, if there's no exponents, and number 5, there were no exponents. As we worked through it, there were no exponents. So the intervals alternate. I'll say alternating intervals. Hopefully I'll know what I mean by alternating. It's either true, false, INTER, there it is. Even if there are exponents, if there's no repeated factors, x minus 4 is different from x minus 10. If there's no repeated factors, you expect an alternating pattern.
So the only time you would really need to test every interval is if you're factoring something and you're getting the exact same thing in both sets of parentheses. Okay?
And I'll make up one of those. If we don't run into one in the homework, I'll make up one before the end of class. Number 3.
3. Hey, I don't see an exponent, Tim.
Well, there's going to be an
There's going to be
exponent.
some exponents here. Notice it doesn't say use cut point. You've got to know that's what you do if you're solving an inequality. If there's a
Okay,
less
switch
than, greater than, less than, equal to, greater than or equal to.
Hey, are we going to get to skip the second step here on this one, like we did the previous one? Yes, because there's no
Yeah,
fractions.
Real still. I'm going to try to focus this again. For some reason, it just seems. Oh, okay, same thing. Okay.
Okay. There are no fractions in the original problem. We should be able to find at least one solution cut point, hopefully 2. If we can only find one, then we're probably looking at a repeated factor situation. You ask yourself, when is the left side equal to the right side? And there's really only one correct next step. I'm trying to think, have we even solved an equation like this before? We're going to have to do something. We know we're going to have to distribute the x. We're going to have to get it set equal to 0 because x times x is going to give us x squared. This is going to be quadratic. So we'll have an x squared minus 1x. We'll have to move the 12 over to make it equal 0. Then we'll write our 2 sets of parentheses. It's quadratic, so we need to try to solve by factoring. X times x. X squared, and y'all are supposed to say x times x. What do we know about the signs? They're going to be different. For 12, there's 1 times 12, 2 times 6, and 3 times 4. Which one do you want to use? It's a simple trinomial. 3 and 4, choose the pair that subtracts to give you that 1 right here in front of that x. Play it out in your head. How are we going to get that minus 1x? Should we have a plus 4 or a minus 4? Okay, so that means we need a plus 3. So that's a 3x minus 4x. Yes, that gives us a minus 1x. set each factor equal to 0 to give us the solution cut point here. What are we going to get?
4.
And here, -3. It's the solution cut point. These numbers make the left side equal the right side. Is it okay to have equality in the original problem? Yes. So how are we going to label these things? Closed. There's equality, so closed. What are we going to do with the second step? Skip it. There are no fractions in the original problem. Number 3, we'll draw our number line. Which cut point is to the left? -3, and then a +4. We said they're shaded. Oh, by the way, back at this factoring stage, did we get the same thing inside both sets of parentheses? Did we get an x minus 4, x minus 4, an x plus 3, x plus 3? No? So I'm 100% confident if I were having to guess, I'd either guess true, false, true, or false, true, false. It's one of those. Well, we don't have to guess. We can test a number. Which number do y'all think I'm going to test? Where is 0 located? Interval 1, 2, or 3? 2, I agree. 0 is between -3 and +4. So this is step number 4. We're going to test 0. We're testing it here. The original problem will have a 0 times 0 minus 1 is, well, it's -1, but 0 times -1 is, 0 is less than 12. True or false? True. So what are we going to do? Shade. That means if we had tested -4 or -10 right here, what do we expect to happen? Shade or cross out? Cross out. So as we tested 5, what do we expect to happen? Cross out. False again. So step number 5, interval notation, call it out as if you were typing it in. Am I going to have to use that U symbol on the toolbar? No, there's only one interval. How are we going to type that in? Call it out as if you were typing it in. Bracket, -3, comma, 4, bracket.
Good.
Good. This is a closed interval. It starts and ends with closed circles. An interval like that is called a closed interval. Any questions there?
It's either going to be either the middle or,
Okay, so
one or the other.
you only have to test one interval. Okay? And
Because there's no repeated factors. It's just x minus 4 and x plus 3. Two different factors. If it could be factored as a quantity square, that's when you have to check every possibility. If it had factored x minus 4, you would have needed to check every one of the intervals. Okay? Distinct factors, you can assume an alternating pattern.
even though we don't have any intervals in our answer, I remember semester students having so much trouble. Where does 0 go? I remember once
I don't
saying,
recall that.
Well,
I mean,
this
it
was
was
my
your class. I know.
The student said, the 0 keeps moving around. No, 0 is never between two negatives. It's not between two positives. It's between a negative and a positive. the end of this semester, when you're through with this class, and someone comes up to you and says, I heard you had one of those Precella twins for algebra. Tell me something you learned. You can say, well, I can find 0 on a number line.
On a real number.
On a real number. Well, there's no such thing as a complex or imaginary number line.
It just sounds
a number
better.
line is a
If
number
we're going
line.
to say something that sounds fancy, say a real number line.
Oh, look at what I did wrong, typing this in. There, okay. And now I need to come over here and close it.
Any questions there? Okay, problem number 4. Are we going to get to skip the second step? No, because what does the problem have? Fractions. Okay. Okay, number 4. I'm going to write small. I think I can get this problem done on this half a page here. -3 divided by x minus 3 is greater than -1.
Maybe set it up the way you did number 5.
I'm going. That's what I was going to do.
I was going to say if you needed me to,
No.
I'll just zoom it here.
No, this is good. Okay, the first thing we do, ask ourselves, when is the inequality equal? So this is step 1, -3 over x minus 3. When does it equal -1? I'm going to make this look like a proportion so I can cross multiply, putting the -1 over what? 1. And then we multiply -1 times, -3 times 1, -1 times x minus 3. -3 times 1 is -3. Take the -1, you're going to have to distribute it over x minus 3. What's that going to give me? -1x, keep going, plus 3, I agree. -1 times x gave me that -1x. -1 times -3 gave me a +3. Any questions there? If we're trying to solve for x, am I going to have to factor? There's not any x squares. There's no even, what I call even multiplicities, the exponent on the factors. So I think the thing to do is to pick this x up and move it to the left, because it's going to give me what? When I move that over, it's going to become +x equals, what am I going to have to do with this? Add it. 3 plus 3 gives me, so I have one solution cut point. And how am I going to label that? Open or closed?
Open.
Okay, there's no equality, so I agree with an open circle. Step number 2. We see that there's a fraction, so set any denominators that appear not equal to 0 and solve for x. So we don't want, this is step number 2, we don't want that denominator to be 0. That means x cannot equal. Moving that over, we get x can't equal 3. That's my denominator cut point. Denominator cut points are always open. It doesn't matter what that inequality is. You never want a denominator of 0. Third step, what am I going to do? Draw your number line. Y'all remembering the steps? And 6 and 3. Which one's going to go here? 3 and then the 6. They're both open. It was all linear. No x squares, no factoring. So we can assume an alternating pattern. If we were running out of time, we could just guess either true, false, true, or false, true, false. But we don't have to guess. Let's test an interval. What do y'all think I'll use as my number I'll plug in? 0. Which interval contains 0? Interval 1, 2, or 3? 1. Now realize you could use 50 million. If it's true at 50 million, it'd be true at 7. You could use pi, and if you were going to test here, you could use 3.14 blah 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 pi. But use something that's easy to test. I think 0 is the easy number to test. And which interval did y'all say contained 0? 1. Right here, we're going to test 0. This is step number 4. Test 0. That gives me a -3 divided by 0 minus 3 is a -3. Is that bigger than -1? Did y'all follow that? I plugged in 0. -3 was on top. 0 minus 3 is -3. -3 divided by -3. What does that give me? -3 divided by itself is a +1, is bigger than -1. True or false? True. So we shade. Suppose we had tested that pi, 3.14159, blah, blah, blah. Would we expect it to be true or false? Suppose we had tested 5. Shade or cross out this middle interval? What do you think? Cross out. Suppose we had tested 7. Shade or cross out? Shade. Step number 5.
Slide it up.
I'm going to do this now. Okay. There. Now call it out as if you were typing it in. What are we going to start with, a parenthesis or a bracket? Parenthesis. Be careful. It must go left to right. That you have no idea how many times people write 3 negative infinity, and it'll count it wrong, and it won't tell you, hey, you messed up. You should be going small to big, okay, or left to right. So be careful. That's a common mistake. What are we going to start with here? Negative infinity, comma, and then the 3. What's going to go after the 3? Another parenthesis, union, parentheses, 6, comma. Oh, yes. That's okay. Good. Any questions there? Negative. Parenthesis, negative infinity, comma, 3, right parenthesis, union, left parenthesis, 6, comma, infinity, right parenthesis. This interval is saying every number to the left of 3 on the number line, not including 3, just the numbers to the left of 3. What is this interval saying? How would you express that in words? All the numbers to the right of 6 are bigger than 6? Yes.
If you found a really old math book before computers and stuff, there would always be a lot of writing, words rather than the symbols. Okay? But this is just a symbolic way of saying every number to the left of 3, not including 3. Every number to the right of 6, not including 6. This is just shorthand notation. This one right up here, the previous answer, that's a shorthand way of saying every number between -3 and 4, including -3, including -4.
We could express that same interval using a compound inequality. All the numbers between -3 and +4, and including -3, including positive 4. But they want interval notation.
5 we've done. 6 is the next one.
Right? Yes.
And of course, this is going to have a z instead of an x. So a lot of times students will show me their work and ask, where did they do wrong?
Well, they changed the z to
became a 2.
That thing on the right, I bet you people will write as 22. So, okay, this is number 6. We can't change the variables any more than y'all can change it. We're just stuck with that z. We could write. I know we could change it, but then I don't want people starting to think when we start typing, say equations of circles, they're going to change those variables. No. Okay, you can unzoom it. I think that will be fine.
Oh yeah.
Okay, there. Hey, are we going to be able to skip the second step? No, because we see a fraction. No, this still isn't that bad, okay? Let's just hope we don't get repeated factors, because then we'll be able to assume an alternating pattern. Let's see. Step number 1. Replace the greater than or equal to with an equal to. Now, what do you think I'm going to do to solve this? I'm going to put it over 1 and cross multiply.
This one's
There
good because
and
it
there.
has some factoring that we haven't done yet.
Yeah, this is a good problem. Z times 1 is Z equals, we're going to have to distribute the 2Z times the Z minus 9. What's that going to give us? 2Z times Z is 2Z squared minus 2Z times 9 gives me 18Z. Y'all are really on the ball today.
Whatever that means.
They are.
Yeah.
The vocal minority is really learning how to do the cut point method, okay? I know that's terrible to say, but it's the vocal minority. We haven't solved an equation of this form. We haven't factored like this before.
But it's actually the easier factor.
It's the easier type of factor, and that's why we haven't run into it before. Notice something. We have that square, so we're going to try to factor it. That means, now I don't want to pick up that 2z squared and move it to the left because the 2 would become negative. So let's move this z here over to the right. So we're going to have 0 equals, we have a 2z squared. Moving that z over, be careful. We have a negative 18z. What's that going to become? Are we going to add or subtract z? Subtract z, negative 18z minus 1z. What's that going to give us? Okay, good. There are only 2 terms here. The most basic form of factoring. I claim we have a common factor. Both of these terms have a common factor as z. We're going to reverse the distributive property. When we're doing the trial and error, we're reversing the FOIL method. Here we're reversing the distributive property. Pull out a z, and what do we have left? Okay. Z times what is going to give me a 2z squared? 2z, okay. Minus z times what gives us that minus 19z. I've already written the minus 19. Any questions there? It seems, I know it's hard to believe, but it seems to me this is the first time we factored out a common factor this semester. Any questions? We're reversing the distributive property.
And is it clear why we're doing it this way instead of the other way? There's not a constant.
If you're going to use reverse FOIL in trial and error the way we always do it, there has to be 3 terms. A square, unsquared, and a constant. There's only 2 terms, so we can't use the reverse FOIL trial and error method. Let me ask you something. Did we get we have two different factors. We have z, 2z minus 19. I think I just answered the question. We didn't have that I was going to ask. We didn't get the same factor twice, so I can assume an alternating pattern when it comes time for checking. One of the factors is z, the other factor is 2z minus 19. So we'll be able to just assume an alternating pattern. That'll help us. So we have z equals, set the first factor equal to 0.
And that's a common mistake. A lot of times students forget to do that. This z is one of those factors. I like the way you put it in parentheses, so it's obvious, or more obvious. Here's one of the factors.
And then the other factor is 2z minus 19. Oh, and notice, there's no solving for this one. We already have one of our cut points, 0. Set 2z minus 19 equal to 0. What do we need to do to solve this for z? I add 19 to get 2z equals a positive 19, and then divide by 2. So I'm getting two solution cut points. 0. There's one of them. And 19 halves. I'm circling it. That's not a final answer, okay? But I just want us to be able to spot them easily. So
and I
I
want to
circled
make sure
them.
they don't forget that that's a cut point right there, the 0.
Now, what's my favorite number when it comes? We get to the number line. What's my favorite number to plug in to check? Will I be able to use 0 now? You can't check a cut point. 0 is a cut point, so I'm going to have to use something else.
Maybe I'll do it.
Yeah, that's probably what I'll use. Okay, for the solution cut points, open or closed? I heard both. I heard open and I heard closed. I'll tell you right now, one of those responses is correct. Okay, now, closed because of the equal sign. These numbers make the left side equal the right side. 0 and 19 halves make the left side equal the right side. Is equality acceptable? Yes. You have that little horizontal bar. So that's going to be a closed dot.
I think finding the denominator cut point will be less steps.
Yes. Second step, you set any denominator in the problem not equal to 0 and solve. So z minus 9, we don't want that to be 0. That means z cannot equal. Getting the z by itself, what number are we going to have here as our denominator cut point? Not negative 9.
I heard
Positive 9. Oh, okay, good. Positive 9. And how will I label my denominator cut point? If you plugged that 9 in, you'd get 9 over 0. Do you ever want denominators to be 0? No. So how will I label the denominator cut point?
Open or closed?
Open. As I said,
open means not including. So not
always label denominator cut points with an open circle. Any questions there? What are we going to do now? Draw my number line. So here's step 3. I'm going to draw my number line. And there are 3 cut points. So be careful. They have to go small to big. We have 0, we have 19 halves, and we have 9. Which one goes first? Which one's the smallest cut point? 0. Now 19 halves, maybe you want to think of that as a decimal. 19 divided by 2 is 9 and a half. So what's going to go next? 9 or 19 halves? 9 and then the 19 halves.
Do the circles.
Okay. How do we label 0? Open or closed? No, 0 is closed. Okay. And then 9 is, that's the one that's open. 19 halves, it's another solution cut point, so closed. Even though we have 3 cut points, we had no repeated factors, so I'm 100% confident this is going to alternate. It's either going to be true, false, or it's going to be false, true. Well, we can't test 0. What number do you want to test? Something that's easy to plug in. 1, okay. Which interval contains 1? Interval 1, 2, 3, or 4? 2, it's right here. 1 is between 0 and 9. Notice I don't put the little 1 and label it there because I don't want it to, it's not going to appear in my interval notation at the end. That's why I don't label the numbers, the test numbers on the number line. I just label it like this. Let's test 1 and see what happens. Plugging in 1, we get 1 over 1 minus 9 is a negative 8, is greater than or equal to 2 times 1. What are we going to get when we plug in 1 there? 2 times 1 is 2. True or false?
The number on the left.
What sign is this number on the left going to have?
It's
Negative. Negative is bigger than 2? No. Cross out. Any questions there?
Now it falls out. Shade the rest of it.
If we had tested negative 1 over here, it would have been true. Suppose we had tested 9.1 here, true or false? True. Here, shade or cross out. So false. Fifth and final step, interval notation. Call it out as if you were typing it in. So they can see the whole problem. There. I'm waiting for y'all to call it out. I'll get it started. Parentheses or bracket? Parentheses, because what goes first? Okay, it always goes left to right. And a common mistake is people write 0, negative infinity. And my math lab isn't going to tell you how you messed up on your interval notation. They're just going to say wrong. So you have to go parenthesis, negative infinity, comma, and then you have 0 and the bracket, union from the toolbar. Now this interval, you have to go left to right. Call it out as if you were typing it. I couldn't hear you. Parentheses, 9, comma, 19 halves. And what goes after the 19 halves? A bracket.
You know, this is a prime problem to illustrate the think about method. Go home and just think about it. Without using these steps. Just look at the problem and think about it.
Well, before it can change from
answers.
Less than to greater than, it has to equal.
Well, that's what
or
you're
it may
doing
just
here.
or it may just be undefined.
But then you're doing this.
I know.
Oh, okay.
That's what the think about it should have been. They should have had those little steps there saying, here's how you think about it. Where is it equal? Where is it undefined? Everywhere else, it's either greater than or less than, and that's the only time it can change from greater than to less than, or vice versa. 9, 19 halves.
Okay, I had a student once send me an email telling me that Pearson had messed up. And this is exactly how they had it typed. Notice, they can't even tell them what's wrong. I suspect with AI, you think real soon, there'll be an AI thing that'll, you messed up on your, what did I do wrong here? The bracket. I think that real soon, but not this semester. That fix that.
Any questions? Okay.
Now,
Number 9.
wow.
No. Anytime we're solving inequalities this semester, I'm going to use cut points. Here's an absolute value inequality. We solved absolute value equations on Monday, and if you're using cut points, what's the first step? Just tell me in general, what's the first step you do? You have to make it equal. That's why we practice solving those equations on Monday, because you're going to have to solve the equation when you're solving the absolute value inequality. Now remember that? Solving the, switch it over.
See, we're now going to use the stuff from Monday.
That's that same.
There you go. Equal positive, equal negative.
Look at this. Do y'all remember this example that I made up? And I said, if you have an absolute value and it's not isolated, you have something added or subtracted from it, before you do anything else, you get that absolute value by itself. Y'all remember that? Let's look at number 9. The absolute value of 4x plus 2.
Not a 14x plus 21.
Oh, here's a minus 14 is less than negative 4. If you're solving an absolute value inequality, just like when you're solving an absolute value equation, the first thing you need to do is make sure your absolute value is isolated. Is it isolated by itself on one side here? No. What do we need to do to that minus 14? Add 14. So we're going to add 14. Add 14 to both sides. So just like when you're solving equations, the first thing you're going to want to do is isolate the absolute value. Adding and subtracting from both sides of an inequality doesn't change the inequality. It's just a less than. Negative 4 plus 14 is a positive 10.
Will you use the original problem anymore, Tim?
No. Notice what I'm about to do. As soon as I have the absolute value isolated, I'm marking out the original problem. You make fewer mistakes. Students make fewer mistakes if they only work with the revised inequality from here on in. Let's pretend that problem doesn't exist.
Because there's no way you made a mistake. All you did is add 14, negative 4 plus 14 is a 10. This is the one we're going to use from here on.
Okay, let's solve this inequality using, hey, are we going to, is there a step here we'll be able to skip? Step number 2, because there's no fraction. So, first step, replace the inequality with an equal to, so you have the absolute value of 4x plus 2 is equal to 10. We have an absolute value equaling a positive number. You have to remember what we were doing 2 days ago. The only way an absolute value can equal positive 10 is if this step inside there is equal to 2 possibilities. What are they?
I'll get them going. Positive 10
or negative 10. Y'all remember doing that? It's going to
equal positive, equal negative stuff from the last time.
So 4x plus 2 will either have to equal a positive 10 or it'll have to equal a negative 10. We're finding our solution cut points. Hey, are we going to have to factor anywhere out here? Think there'll be any quadratic factors? Do you see any exponents? No? So I'm 100% confident once we get that number line drawn, it's going to alternate either true, false, true, or false, true, false, but it's going to alternate. So what will I do here? minus the 2 to give us 4x equals 10 minus 2 is 8, and then divide by 4 to give us x equals 2 for my first solution cut point.
Are y'all caught up? This is the same stuff now that we were doing the last time. Equal positive, equal negative. How do we know to do that? Well, it's absolute value.
It's an absolute value equation. That's how you solve absolute value equations. So move the 2 over here. That's going to give us 4x equals negative 12. I agree. And then to give us x equals, how are we going to label these cut points? We have 2 cut points, 2 and negative 3. Open or closed? Open, because there's no equality. These numbers make the left side equal the right side. There's no equality bar up there, so these will be labeled open. And the second step, you skip it because there are no fractions. You know, since this is the first absolute value inequality we've done today, I'm going to write that out. Skip because problem has no fractions. Third step, draw the number line, okay.
Are we going to be able to use 0 as our test number? Yeah.
Yes. Which cut point will go first? 2 or negative 3? Okay, remember it goes small to big. So negative 3 and then positive 2. And as I said, there's no time. We didn't even have to factor. It's all linear. So I'm 100% confident that it's going to have an alternating pattern. So step number 4. What number do y'all think I'll test? 0. Which interval contains 0? Interval 1, 2, or 3? 2. It's between negative 3 and positive 2. So, we're testing this rewritten inequality. Remember I said mark that out. Use the one that was rewritten. So you have the absolute value of 4 times 0 is 0. So you have a 0 plus 2. 0 plus 2 is 2. What's the absolute value of 2? 2 is 2 less than 10. True or false? True. So shade or cross out. Shade. If we had tested negative 4 or negative 5, shade or cross out. Cross out. If we had tested 3 or 10, shade or cross out. Cross out. Are we going to have any infinities or negative infinities in our answer? No. Call it out. This is number 5. Step number 5. Call it out as if you were going to, as if you were typing it in. Parentheses, negative 3, comma, 2. Are we going to use a union? No, there's only one interval. Any questions there?
Now, usually, if you're a view and example person, usually if you look at what we're doing and what the view and example is doing, it's pretty darn similar. Not for these absolute value inequalities. Okay?
The absolute value inequalities, if you view an example, they're giving you some generalizations involving absolute value of linear expressions and telling you set it up like this as a compound inequality or two disjoint inequalities. So
why try to memorize more rules?
When this thing will take care of
The cut point method will solve any inequality. You don't
Where
need
is
to
it
memorize
equal?
more rules.
Where is it
or
undefined?
Try to come up with different. In fact, maybe we should go on and do number 11 or 12 right now.
Number 12.
Okay. Don't panic till you see it.
These people are very calm. This group
I
of
know,
students,
they
I
don't
can
really-
tell that they're
They don't even
calm.
laugh when I say that. I mean,
They're very calm.
yeah, they're just very calm and laid back.
I like our sister. Whoa! Whoa! I never knew my sister was so. Whoa! Every time you approach a speed bump in the car and you touch her, whoa! Or she's watching something, whoa! Whoa! The cat jumps up on the counter or something, whoa! So she's very easily excited. She'll never figure out how to watch YouTube, so I can say anything I want to. She'll never see the video anyway, so.
But she does. Say what?
She does. She's.
Now,
Hey, are we going to have any denominator cut points here? No. What do I see? There's one thing I see that says use cut points. And every time you see one of these this semester, I don't know what you're using, but I'm going to be using cut points to solve it. What is it that says use cut points?
because the instructions don't say it. The inequality.
That inequality.
Less than or greater than.
That's what says to use cut points. And the instructions don't say use cut points. That means the instructions on the test aren't going to say use cut points. You've just got to know it's an inequality, so use cut points. The first thing we're going to do. Oh, and what did y'all say? Are we going to have any denominator cut points? No, so no matter how bad this problem is, at least we get to skip step number 2. But here we go.
Wait, let's review something that we did.
I know, I was going to write it. First step, let me do this. The first step, we replace that greater than with,
Equals,
and now, let's review something that we did the last time.
This was an example you quote made up.
Actually, I just looked at number 12 from this assignment today, and y'all remember that? That looks familiar to me. The absolute value of x squared plus 2x minus 19 is equal to 16. This is the little example that I made up the last time. Okay?
Positive and
So we'll have to go equal
negative.
positive, equal negative. Do y'all remember that? So we're going to wind up having 4 cut points. That's okay.
You still
We
just
have
have
an
to,
absolute value equaling a positive number, so the stuff inside there will either be positive 16 or negative 16. So we have an x squared plus 2x minus 19 equals a positive 16, or x squared plus 2x minus 19 equals a negative 16. Oh, I think this blue pen that I like so much is about dead. I can't even see the ink in there anymore. Oh, shoot. Okay, there's only one correct first step to solve this equation. But before we factor, it needs to equal 0. Where are you going to get the 0? On the left side or the right side? The right side, I agree. So to get a 0, what are we going to do with the 16? Subtract 16. To give us x squared plus 2x. Negative 19 minus 16, is that a minus 35? Equals 0. I remember when we were doing that assignment over factoring, I said to y'all, there weren't very many simple trinomials in that assignment to factor. But I said, you'd be surprised how as the problems get messier, my lab has a tendency to generate problems with simple trinomials just so it's easier for you to factor. This isn't that bad. X squared, there's only one possibility. What is it? X times X. Uh-oh, what about the signs? I couldn't hear you. The last sign's a minus. So we're going to have a negative and a positive. 35, it's either 1 times 35 or 5 times 7. Which one? You can, with a simple trinomial, you can choose the pair. In this case, that subtracts to give you that number 2. So I agree, 5 and 7. Play it out in your head. We want to get back a plus 2x. So should it be a plus 5 or a plus 7? The plus 7. I agree. Which means here is the, okay. And if you check, your outer product is a 7x minus 5x. That gives us a positive 2x. Then what do? Set each factor equal to 0.
X minus 5 is 0, or x plus 7 is 0.
To give us x equals a positive 5, or here, a negative 7. Those are my solution cut points, 2 of them. I'm not through finding solution cut points, but I've got 2 solution cut points so far. Will they be open or closed? Open. Notice there's no equality. These numbers make the left side equal the right side. There's no horizontal bars, so open. And now this possibility, what am I going to do first? Okay, add the 16, good. That's given me x squared plus 2x minus 3 is equal to 0. And then we have x and x. Hey, what times what equals 3? I think there's only one pair of whole numbers. 1 times 3. So, what do we know about the signs? 1 plus and 1 minus. Where's the plus going to go to give us back the plus 2x? Okay, the plus there, the minus there. That's a 3x minus 1x. I agree, that gives me a positive 2x. Any questions? You know something? If you like looking at this display, you can turn that table around. That has to hurt your neck.
She's young.
Yeah, it doesn't. You're right. But for me,
my neck's
yeah.
hurting.
But you feel free. Turn that table to face whichever display you want to look at, okay? You don't have to sit there like that. I would think that would hurt my neck, you know. My arthritic-ridden neck would hurt. Uh-oh. Set each factor equal to 0.
Oh, but what I was about to mention was, are any of these factors repeated?
Yeah. I was going to find them all and then mention it. Yeah. But here, look at this. Did we get x minus 5, x minus 5? No, we got 2 different things inside the parentheses. Here, 2 different things. So, are we going to have to check every interval? We can assume an alternating pattern. We have 2 other solution cut points. What are they? Here, 1. Here, and negative 3. And once again, they're going to be open. That's the longest part of the problem. Do you all agree that's going to be the longest part? The second step, denominator cut points, we've already said what? Skip it. There's no fractions in the original problem, so we just skip it. Third step, I'm still numbering the steps. I was only going to do that for the first few problems, but...
marks.
Okay, 1, 2, 3, 4. Okay,
Open circles.
and they're all open circles.
Put those numbers in numerical order, left to right.
Okay, which one's the first one? Which number's the smallest cut point? No, -7. I was about to go with the -3. Thanks. Okay, I did. Okay, so next, then the -3, and 1, and 5. There are 5 different intervals, but because we know these things are different factors, we know it's going to have to alternate. So, which number do you think I want to test? What's the easiest number for me to test? 0. Which interval contains 0? Interval 1, 2, 3, 4, or 5? 3. It's between -3 and +1.
Zero's always between negative
Negative
and
and
positive.
positive. That-
Never between two negatives. It's never between two positives.
So we're going to test 0.
Oh,
Here
and
we
this is a
go.
little tricky.
This is, be careful. We have the absolute value of 0 squared is 0, plus 0 times 2 is 0, minus 19 is bigger than 16. True or false?
Be careful. What number? 0 plus 0 minus 19. So inside these blue absolute value bars, we have what number?
Negative 19 is inside those blue absolute value bars.
Before you can decide between true and false,
You better take the absolute value. The common mistake is people say negative 19 is greater than 16, false, cross it out.
wait,
You've got to take the absolute value, though.
what's the absolute value of negative 19?
19 is bigger than 16. True or false? True. If you're only going to check one interval, you better make sure that you check it correctly. Don't forget to take the absolute value. That's a true statement. So if I tested -4 here, shade or cross out? Cross out. If I tested -8 here, shade or cross out? Shade. Oh, I need a different color for this shading. It stands out better. There, there. So suppose I tested 2 here, shade or cross out? Cross out. Over here, shade. That was step 4, the testing. Step number 5. We're going to have to, we have 3 different intervals. Are we going to wind up using that little U symbol in our answer? Yes. Okay. So, parentheses, negative infinity, comma, -7, close the parentheses, union, parentheses, -3, comma, okay, union, parentheses, 5, comma, and what goes after the infinity? Good. Oh, goodness.
Get over here and type all that in. Parentheses.
Negative infinity, comma, -7,
-7.
right parenthesis, union, open, -3,
-3, negative. No,
Number
positive
1.
1. Close parentheses. Union. Parentheses 5, comma.
infinity,
Close parentheses. Check the answer. And we're not finished. Now, they want us to choose the graph. On this graph, they're not using closed circles. Can y'all tell what they're doing? They're using the parentheses and brackets instead of the open and closed circles. But okay, doing that, which one of these is the correct?
What would we have here is we were going to use parentheses and brackets. The open circle would have what? A parenthesis. I don't like using parentheses on the number line because you have to face it towards the shaded number, the shaded interval. Well, when you're labeling these cut points on the number line, do you know which direction you're going to be shading? No, so you wouldn't know, do I make the parenthesis face left or face right? But
okay. I'm thinking A is the answer.
Is that what y'all said? A? I agree.
And you might wonder, why the heck, it seems like you sort of have to have the number line before you have the answer in interval notation. If you're a view and example person, please, please, please don't do that.
This is a doozy, what they have here. Well, first of all, look back at the work. Look back at this work that we just did. The longest part, I believe, is step 1, factoring and finding those solution cut points.
And how many number lines do you draw when you're doing these?
Throughout this, for each problem, how many number lines do you get?
Only
one number line, okay? But the longest part is factoring. So if you view an example,
they're going to use a method that turns out their logic doesn't work
if it's greater than.
If there's a less than. The less than 16 instead of greater than 16.
Their logic, what they do in that view and example, only works if this little thing here is always a greater than. If it's a less than, their method just completely falls apart. Look back at this. Turn back here. Suppose instead of a greater than, this had been a less than. Would any of this first step change? If instead of a greater than, we'd had a less than. Would any of this change? No. You draw the number line, and when you're testing, instead of getting true, false, true, what would you get? False, true, false. The cut point method, it doesn't matter whether it's less than or greater than, the method still works. Their view and example method only works if the inequality is a greater than. And let's see, we're going through this.
Just hilarious what they're doing. Can I make this bigger? Maybe not.
Mm-hmm.
Look, they still have less thans. They have greater thans and less thans. Okay.
And then they start talking about polynomial functions, which we have not even defined at this point in the course.
At the point where they're doing the first factoring.
And then make a number line.
After doing right here, we don't need to draw a number line and just do these two numbers. They're going to draw 3 number lines on this. Okay, so they tested with just those 2 and got an answer. Not the answer, but an answer. And then they start all over. It's absolutely...
It's sheer madness. It is. They have another number line with all new intervals that aren't the answer.
And then in a moment, they're going to do some hocus pocus, and right here they come up with the answer. Okay? And from that answer,
they then draw a number line. It's sheer madness. It only works if you can call that work, and it only works if the problem says absolute value greater than a 16 or greater than a number. If it were a less than, none of that works. It's just garbage. So
if you find yourself, if you don't do anything today other than problems 11 and 12, because those are the ones, isn't 11 the exact same type?
Yeah, they can't do one with a less than because their little method doesn't work. If it's a less than, so it's another one that's a greater than. Y'all want to do another one of these? These are quadratic absolute value inequalities.
You can
impress people with this. Okay?
I mean, even tutors, you can impress them. Okay? Remember, years ago, a tutor telling me, I don't know. I mean, that cut point method of yours is just really incredible. It's not mine. I'd love to take credit for it. It works everything. Every inequality, it'll solve it. I don't understand why, but it works.
To me, it makes perfect sense.
Uh-huh.
Where is it equal? Where is it not a number? Anywhere else, it's either less than or greater than, and it can't change from less than to greater than without going through equality or undefined.
You want to go ahead and do number 11?
Yeah, let's do number 11. And then I have one that doesn't alternate, okay? So,
Let's do it quickly so we can get it done. We have an hour and 39 minutes. Let's try to get it done by 2 hours.
that's the problem. Is it all hitting y'all in the face? Just hitting you in the face and bouncing back? Is that what's happening? Y'all are getting quieter and quieter. Maybe as we go on and on about how great it is, we're getting a little too passionate about this, Tony. It's making him a little uncomfortable.
I really do think that solution, these cut points are the best thing ever.
Since sliced bread, maybe? The best thing since sliced bread? Our grandmother used to say that. As a child, I didn't think sliced bread was that great, okay? But Grandma Lily used to say that.
Okay, so we start off by saying, why don't you just get to the chase, equals 22 and equals negative 22.
So we have an x squared plus 3x minus 32 equals positive 22 and equals negative 22. Gosh, there. And let me do that. So we'll subtract 22. That's going to give us x squared plus 3x. Negative 32 minus 22 gives us a minus 54 equals 0. Notice at least they're being nice. They're giving us simple trinomials. So x squared, x times x. What do we know about the signs? Positive and negative. I know y'all want to get out of here, so I'm going to just do it for you. A plus 9 and a minus 6. Positive 9 times negative 6 gives us the negative 54. Negative 6x plus 9x gives us the positive 3x. So we're going to get two solution cut points. What are they? Here, x equals negative 9, okay. And here, x equals 6. Their solution cut points, open or closed. Open. Okay, let's add 22 here. We're going to get x squared plus 3x. Negative 32 plus 22, I heard you say. Minus 10, I agree. Y'all are ready to get out of here. This stuff is just hitting y'all in the face. So what is it? An x plus 5 and an x minus 2. And that's going to give us two additional solution cut points of x equals negative 5 and x equals 2. Once again, solution cut points labeled open. Denominator cut points. Skip. Draw our number line.
Hopefully it's clear why we're doing equal positive, equal negative. Okay? It's not the greater than that tells us that, it's the
Fact that it's an absolute value.
You sort of got to be able to distinguish this stuff.
And we have open circles. And we need to label these things small to big. Which one's going to go to the left? Negative 9, and then negative 5, 2, and hey, look back at the factorization. Did we get repeated factors? Did we get the same thing, x plus 9, x plus 9, or x minus 6, x minus 6? No, every factor is different, so we can assume an alternating pattern. So we only have to test one interval. What number do y'all want to test? 0. Which interval contains 0? Interval 1, 2, 3, 4, 5. 3. So we're testing 0 right here. That's going to be a 0 plus 0 minus 32. Don't forget the absolute values. The absolute value is that greater than 22. True or false? True. The absolute value in negative 32 is a positive 32. Is that bigger than 22? Yes, it is. So shade. Here. Cross out. Here. Shade. Here. Cross out. Here. Shade. Am I going to have any square brackets in my interval notation? No. Everything's going to start and end with parentheses. So, you had a question?
No, I
Joe?
was going to say, if you work with a tutor and your tutor's helping you with them, show them what we're doing here. Okay?
Okay, let's write out the interval notation. Call it out. My voice is getting sort of tired. So, parentheses, comma. I agree. Oh, is there a Caitlin Mills here? Do any of y'all know your classmate Caitlin Mills? She's won a scholarship and she's about to lose it because she hasn't claimed it yet. So, if you know Caitlin Mills, use tell them that to go to the foundation office. Claim your scholarship.
Or contact you.
Or contact me and I'll tell you what to do.
Is that it?
Mm-hmm.
Okay. Oh, wait. Now, which one of the graphs was it?
A, B, C, or D? Which one? Once again, they're putting the parentheses in place of the open circles.
They've done the hocus pocus and come up with the answer before they drew the number line.
Which I just find.
Yes. Tim, here's one that
No.
does not.
I have one.
Okay.
Well, it's pretty easy to make it up, okay? Make up one.
Here's one real quickly that doesn't alternate.
How about x squared plus 8x plus 16 is less than 0. Are we going to have any denominator cut points? No. We know that we're going to use cut points to solve this because I see that inequality. Oh, and by the way, I didn't put absolute values. I just want a plain problem like number 1. So we set it equal. And then we'll draw our sets of parentheses. We're going to factor it because it's quadratic. X squared is just x times x. Signs. Positive, positive. The last sign's a plus, so you have 2 of the first signs. So positive, positive. And 16. 1 times 16, 2 times 8, or 4 times 4. 4 times 4, look at that. We have repeated factors.
Y'all see what we mean finally about repeated factors?
We have the same thing inside both sets of parentheses.
How many cut points are we going to have here?
Are we going to have 2? No, just 1. Set x plus 4 equal to 0, and we get only 1 cut point, negative 4. Open or closed? open. There. Draw. Oh, I don't guess I needed such a long line because I only have one number to label. -4. I would just normally, if I had different factors inside those parentheses, I'd only test one interval. But the fact that we have repeated factors makes me think this may be an exception. It may not be true, false. It could be true, true, or false, false. We may have 2 consecutive true or 2 consecutive false intervals. Let's see. Let's test a number right here. To the left of -4, I think I'll test -5. Y'all agree -5 is over here to the left of -4, right? So -5 times -5, that's a positive 25. Positive 8 times a -5, that's a minus 40. What else do we have? Plus 16 is less than 0. 25 plus 16, I know that's 41 minus 40. I'm getting 1 is less than 0. True or false? Right? 1 is less than 0. That's false. False. 1 is not smaller than 0.
Cannot assume the next one's true.
Because of those repeated factors. Hey, 0's to the left of -4. Let's take the easy way out and test 0. So we'll have a 0 squared, which is 0, plus 8 times 0 is 0, plus 16 is less than 0. I think it's another false, isn't it? Is 16 smaller than 0? No. Is there anything on that number line shaded? This would be a no solution situation.
Some of them have, let's see.
Probably say the solution set is empty or something.
Well, here it says,
No.
okay, that's.
No.
Did any of these, for that one, it would have had to say no solution.
It'd have to have been a no solution
would be,
option.
and I guess there weren't any. I thought there was some. Oh, like this one. Here's one where it gives you the solution set as the empty set. I don't know if that ever happens. I don't see how.
I don't think it regenerates so that it's empty. As everyone I've done of number 3, it's always got a solution. But I just wanted to show you, if you have repeated factors, the same thing inside the parentheses, that's where you could run into the weird things where you have 2 consecutive true or 2 consecutive false. But here's my advice to you as you do your homework. If you run into a true, true, false situation, I'd go back and check my work. Odds favor you've messed up. Any questions there? There's a lot to think about, okay?
But it's a method that will solve anything that has a less than or greater than.
Trigonometric inequalities.
Yeah, anything.
Where is it equal? Where is it undefined? Anywhere else it's less than or greater than, and it can't change except at those cut points.